Hello student, welcome to my YouTube channel Chem Study. Myself Dr. Ajit Ingle, Assistant Professor, Department of Chemistry, Dada Patil Mahavidyalay, Karzat, District, Ahmednagar. Student, today we discuss about the types of organic reaction. Then what is the learning objective of this lecture? We learn about the definition of nucleophiles and electrophiles. Then we learn about the types of organic reaction. Then what is the nucleophile and what is the electrophile? Which species, which molecule act as an electrophile? Which species, which molecule act as a nucleophile? Then consider the definition of electrophile and nucleophile. Any positively charged species or ion or neutral molecule having vacant orbitals are called as the electrophiles. Electrophiles are electron deficient. They are positively charged. They accept the electron pair and make a covalent bond. All Lewis acids and carbocation act as electrophile. Electrophile generally undergoes electrophilic addition and electrophilic substitution reaction. The positively charged ions are generally electrophiles, and any species or molecule which have vacant orbitals are also act as electrophiles. Then what is the nucleophiles? Negatively charged species or ion or neutral molecule having lone pair electrons are called as nucleophiles. Nucleophiles are electron rich. They can donate the electron pair and make a covalent bond. All Lewis bases and carbanions are nucleophilic in nature. Nucleophiles undergoes nucleophilic addition and nucleophilic substitution reaction. Negatively charged ion like hydroxide, NH2 negative, carbanions are nucleophilic, or molecule having lone pair electron like ammonia, water, alcohol, they act as nucleophile. Then what are the types of organic reaction? Organic reactions are basically four types: substitution reaction, elimination reaction, addition reaction, and rearrangement reaction. What is the substitution reaction? The reaction in which an atom or group of atom in the reactant replaced by another atom or group of atoms of the reagent used is known as the substitution reaction. Depending on the nature of incoming group or the formal charge on incoming group, substitution reactions are three types. Consider the first, nucleophilic substitution reaction. What is the nucleophilic substitution reaction? The substitution reaction in which the atom in the substrate substituted or replaced by incoming negatively charged group, that is nucleophile, to give substitution product. This is known as nucleophilic substitution reaction. Look at this example. Atom X in the substrate replaced by negatively charged atom Y, which is known as nucleophile, to give substitution product. Then consider the second type of substitution reaction, electrophilic substitution reaction. The substitution reaction in which the atom or group in the substrate replaced by positively charged atom, that is electrophile, to give substitution product. This is known as electrophilic substitution reaction. At sp3 carbon or aliphatic carbon, electrophilic substitution is very rare or not generally observed, but in aromatic compound, electrophilic substitution reaction are easily occurs. Look in this example, atom H on benzene ring substituted by positively charged atom bromine to give substitution product. This is the example of electrophilic substitution reaction. The third type of substitution reaction is a free radical substitution. The substitution reaction in which atom or group in the substrate replaced by free radical atom to give substitution product. This is known as the free radical substitution reaction. The nucleophilic substitution reaction are generally occurs at aliphatic carbon or sp3 carbons. The common nucleophilic substitution reaction which is occurred at aliphatic carbons or sp3 carbons are SN1 reaction, SN2 reaction and SNI reaction. Some of the aromatic system also undergoes nucleophilic substitution reaction, and some common electrophilic substitution reaction which is occurred in aromatic system: nitration reaction, sulfonation reaction, halogenation reaction, Friedel-Crafts alkylation, Friedel-Crafts acylation reaction and diazo coupling reaction. Then consider the second type of organic reaction, addition reaction. What is the addition reaction? The reaction in which substrate and reagent combine to form single product which contain mass of all atom of substrate and reagent is known as addition reaction. The compounds having multiple bond, carbon carbon double bond, carbon carbon triple bond and carbon oxygen double bond generally undergoes addition reaction. Alkene, alkyne and carbonyl compounds, aldehyde and ketones undergoes addition reaction. Addition reaction is a characteristic of alkene and alkynes. Depending on the nature of reagent used in addition reaction, the addition reactions are two types: electrophilic addition reaction. In what is the electrophilic addition reaction? In electrophilic addition reaction, in first step, positive part of the reagent add across the carbon carbon double bond of substrate to give positively charged intermediate, that is carbocation. Then in second step, this carbocation attacked by negative part of the reagent to give addition product. This type of addition reaction is known as electrophilic addition reaction. Then consider the second type of addition reaction, nucleophilic addition reaction. The addition reaction in which in first step negative part of the reagent add across the carbon carbon double bond of substrate to give negatively charged intermediate, that is carbanion. In second step, this carbanion combined with positive part of the reagent to give addition product. This is known as nucleophilic addition reaction. The common electrophilic addition reaction which is occurred in alkene and alkynes are hydrohalogenation reaction, halogenation reaction, hydrogenation reaction, hydration reaction, hydroxylation reaction, oxymercuration, demercuration reaction, hydroboration, oxidation reaction, and ozonolysis reaction. All these reactions we have discussed in detail in chapter addition reaction of carbon carbon double bond and carbon carbon triple bond. The third type of organic reaction is elimination reaction. What is elimination reaction? The reaction in which two atoms or group of atoms are removed from the reactant to form the product with higher degree of unsaturation is known as elimination reaction. In most of the elimination reaction, the two atom which is eliminate or remove from the substrate, they are present 1-2 position or they are present on adjacent carbon to each other, This type of elimination generally known as 1-2 elimination. Both eliminating atom present on adjacent carbon or their relative position is 1-2. This type of elimination is known as 1-2 elimination. In 1-2 elimination reaction, if one of the eliminating atom from beta carbon is hydrogen, then this elimination is known as beta elimination reaction. In elimination reaction, there are two bond breaking steps and one pi bond formation steps are occurs. The bond between alpha carbon and leaving group and the bond between beta carbon and hydrogen are generally break, and there is a new pi bond formation occurs between alpha and beta carbon. Depending on the timing and sequence of bond formation and bond breaking, elimination reaction have three types of mechanism. Consider the first mechanism, E2 mechanism, and this reaction is known as E2 elimination reaction. It is a bimolecular reaction. In E2 mechanism, the bond between beta carbon and hydrogen break at the same time. The bond breaking start between alpha carbon and leaving group, and simultaneously there is a bond formation occurs between alpha and beta carbon. This reaction proceeding through transition state. This reaction has one step mechanism. This mechanism are generally known as E2 mechanism. Then consider the second E1 elimination reaction or E1 mechanism. In this mechanism, in this reaction, the bond between alpha carbon and leaving group is break in slow step to form positively charged intermediate, which is known as carbocation. In second step, base abstract the beta hydrogen and pi bond formation occurs between alpha and beta carbon to give alkene product, unsaturated product. This mechanism is known as E1 elimination mechanism or E1 mechanism. E1 mechanism, E1 reaction is a two-step reaction. It is unimolecular reaction. Then consider the third mechanism, E1CB elimination reaction. Elimination proceeding through conjugate base. In this reaction, in first step, base abstract the beta hydrogen and negatively charged intermediate is formed. That is the carbanion, which is a conjugate base of starting substrate. By driving force of this negative charge, leaving group is eliminated and pi bond formation occurs between alpha and beta carbon to give alkene product. The reaction which proceeding through the conjugate base, this elimination reaction is known as E1CB elimination reaction. And the last type of organic reaction, which is known as rearrangement reaction. What is the rearrangement reaction? The reaction in which either the change in carbon skeleton or functional group in substrate occurs to give product which is isomer of reactant or new compound is formed. This reaction is known as rearrangement reaction. In rearrangement reaction, the compound undergoes isomerization. The one functional group can be converted into the another functional group, or in some rearrangement reaction, one compound can be converted into the another compound which is completely different from the starting compound. Rearrangement reactions are generally two types, the intermolecular and intramolecular rearrangement reaction. In rearrangement reaction, migration of group occurs from one atom to another atom. If migration of group or group occurs from one atom to another atom in the same molecule, this type of rearrangement is known as intramolecular rearrangement reaction. And if in rearrangement reaction, migration of group occurs from one atom to another atom in different molecule, this reaction is known as intermolecular rearrangement reaction. Most of the rearrangement reactions are intramolecular rearrangement reaction, and they involves one to shift. The atom migrate from one atom to adjacent atom. This one two shifts are generally involved in intramolecular rearrangement reaction. Consider the example: isomerization of terminal alkene to non-terminal alkene in presence of acid catalyst. It is an rearrangement reaction. The conversion of 1,2-diol into the ketone in presence of acid catalyst is another example of rearrangement reaction. In this reaction, the diol is the functional group in substrate. In the product, the functional group is ketone. This rearrangement is known as phenol-phenolone rearrangement. Then consider the one more example. In presence of per acid catalyst, the ketone can be transformed into the ester. This, this reaction is also rearrangement reaction. And in presence of acid or Lorry Bronsted acid catalyst, oxime of aldehyde and ketone can be converted into the amide. This reaction is also rearrangement reaction, and this is known as the Beckmann rearrangement. Student, in this lecture we have learned the types of reaction. There is four types of organic reaction: substitution reaction, addition reaction, elimination reaction, and rearrangement reaction. And we discuss about the electrophiles and nucleophiles. Then what is the definition of electrophile and nucleophile? Which bases act as a nucleophile? Which bases act as a electrophiles? Thank you. Thank you very much.